Okay, so here's what you're attempting to do on part one. It says, reminder, a solution is made of a solute and a solvent. The percent solute and percent water should equal 100%. For the questions below, record what the solute and solvent are in addition to recording the amounts for each. All right, so the very first solution says Kim made a potassium iodine solution that is 84% water. So the solute is what is being dissolved. In this case, it's going to be the potassium iodide, because obviously it's not water. All right, now it says here, if the solution has 84% water, 100 minus 84 is 16. So there's 16% of this solute. All right, now they've given you water already. So I'm gonna put H2O here. And they told us there was 84% of it, just like that. Okay, now, this part on the top is really not that challenging in my mind. You're literally just doing the calculations, okay? When you move down to part B, it says a cell is made up of 70% water and 30% other substances. If we put one cell in each of the above solutions, decide if the solutions are hypertonic, iso, or hypo in comparison to the cell. So it says here, which solution is hypertonic? Now, here's the deal. You can't really determine these things until you do all of this data up here. Let's attempt just to figure out what Kim's solution is. All right, so Kim's solution has 16% solute and has 84% water. An actual cell itself has 70% water and 30% other substances. So to give you a visual, basically you've got this beaker full right here. And technically you could probably just use the one down here. In fact, I'll just do that instead. So we know that the actual solute is 16% and solvent is 84%. All right, so everything around this is 84% water and inside is 70. So 70% here, 84% here. Now when you see it like this, it's pretty simple. Water flows from high to low. In this case, 84 will flow into 70, which also means that the cell itself is going to expand. Now, one thing I taught you guys, that if your cell is going to expand and get huge, you place it in a hypotonic solution. So the very first solution, Kim's solution, is hypotonic. So I'll come back up here, find hypotonic. So Kim's solution is hypo, and it's because the cell expands. You could also simply look at it based on the solute content. So the solid out here is 30%, or excuse me, inside is 30%. The solute outside is 16%. When your solute is actually lower in the solution, think hypo. Hypo means low. All right, guys, that's essentially it on this page. On this page, you're literally just doing check marks. And I think it's pretty straightforward as well. You're just telling you what kind of solution it's been placed in and kind of what's going on.